All right, Mr. Claxton, digital electronics students, DE students, I wanted to talk to you here about one of the problems. This is number 2 on the activity. I just wanted to make sure that everyone here saw that we had 200 microseconds per division for the scale. So, I mean, what does that look like? So that's 200, and they just use U. And that symbol is actually, the symbol that I had trouble making there, is just a mu. So they use a U, microseconds. So what does that mean? That means that up here we've got 200 microseconds. And this right here would be 400 microseconds. And so each of these smaller intervals right here, we're going to take 200 microseconds. Notice how there's 5 of those. So we would take 200 divided by 5. Now we know what 20 divided by 5 is. That 20 divided by 5 is 4. So 200 divided by 5 would be 40. So each one of those is 40 microseconds. Those little intervals. We'll call those the small divisions. That does provide a problem sometimes to students trying to complete this. With the frequency, you really need to make sure you're showing your work. And that's what I look for when I do collect the assignments, or if I look at a picture of it or whatever. Make sure that we are using the right formula. Frequency is equal to 1 divided by, and that would be the period. Now, you will need to either convert that number to the standard unit. It will be in microseconds, most likely. We see 200, 400, so the period, also known as T. And there's no work for that one. You might say 2 times 200 microseconds per division. That may be, your science teachers might like you to do that. But either way, I'm okay with you not showing any work for the period and just putting 400. Now, there is one that you will want to show work for that will help you out. You do not have to, but it may help you out. Some students would prefer to show work for that, some students not. So you're going to have 1 over 400 microseconds. And, I geeked it out in a video yesterday, that the longer video, the first video about the lesson, to show you how to use those negative exponents, bring them up to the numerator. If you're looking for a shortcut there, or just convert it to standard units, micro, you have to remember that micro is times 10 to the negative 6. So just wanted to make sure that everyone knew that. Remember, duty cycle is expressed as a percentage, and you should be able to estimate that. We know that this start to finish on the period, so from here to here, this one signal is working for over 50% of the time. So that's going to be well over 50%, more like 75%, somewhere around there. We can see that without even calculating it. I can see that. But I do want you to show your work for your calculation. Remember, duty cycle is T sub H, that's time high, and that's divided by the length of the signal, or the period. All right, that's it for now. If you do finish this and want to move on to binary numbers, you can do that as well.